Well, hello CIS 1400 and welcome back to Module 5. First, I want to thank you for your understanding in the changing of the schedule. Somehow in the original syllabus I had 2 weeks built in for an assignment that was never going to take 2 weeks, and I had completely forgotten to about Thanksgiving break. So I wanted to make sure that you got kind of that week in there to kind of rest and relax and be with some family, and again adjust the schedule accordingly for that assignment that was kind of messed up in the first place. So we shuffled a few things around. I think it'll work out best to push the project off till next week. The project we will do will be what we call a reverse guessing game. So you can kind of start thinking ahead at that. What it will do basically is you, the user, will pick the number from 1 to 100 in your head, and you're going to try to let the computer guess it in as efficient a process as possible. So you can start thinking about and planning how you might go about doing that. There'll be further details to come in the next week so that you know exactly what you're going to be required to do. But you can start thinking about how you're going to design pseudocode, flowchart, and program that little bit of logic there. So keep that in mind as you go through. Now, this week, we are going to cover actually 3 chapters of the book, chapter 6, 7, and 12. 6, 7, and 12 are all about functions, which I know some of you have been starting to want to use. Functions are simply modules that return something to us, so they actually give information back to the program that are calling them. Chapter 7, I believe, is all about input validation. We kind of have a saying in programming, garbage in equals garbage out. So if you put bad data in, you're going to get bad data out. So we want to make sure that the data that comes into our programs is actually good data. And then lastly, chapter 12 is all about text. So we're going to teach you about string manipulation and the functions that go along in there, and how kind of introduce sequences a little bit more clearly to you, so that you can start seeing how strings are indexed and how we can break them apart into different things. So we're going to break this up into 3 videos. We're going to talk about functions first, and then we'll talk about validation, or text and validation, as we go through it. So buckle up, we're in for it right now, and let's see how this goes. So first, let's start with functions, because I know some of you have been chomping at the bit for that. So if we recall back in Module 1, all programs had to go through basically kind of 3 processes. So first we had to come up with input, then we had to transform that input in some way, we called it processing, and then we had to come up with some sort of output. The functions we're going to create are going to be no different. We can often kind of plan a function a little bit through pseudocode and flowchart, but also through what we call an Ipo chart, input, processing, output. Realistically, it's really plain and simple. It kind of gives the name for the function. So this is an Ipo chart for a get regular price function. You talk about any input you may have, any processing you may have to do, and any output. And so each column just kind of shows what's happening throughout the function. So it's just a nice little way to kind of lay out your thoughts so that you know exactly what's coming into it, what's coming out, and how you're going to get there. You just need to be able to read them and things like that for right now. I'm not going to ask you to create any per se at this moment, but understand that it could be a very useful tool for you, especially when we're talking via email about any of the functions or modules that you're coming up with. If you have any questions, we can talk about these 3 items as we start to troubleshoot your problems. So keep that in mind. So in terms of functions, functions are very similar to the modules we've been creating, except the modules we've been creating haven't actually returned anything back to us as we go through it. They are just doing some processing and most of the time printing out something for us, which is fine. But sometimes we like to be able to have a function that we can use in other functions, and I'm sure you would have wished to have been able to had one during that paint calculator that we had you build a couple modules back. That would have been useful to calculate, say, the square footage of the wall and the prices per gallon, so that you can use that same information in other modules and not have to recode a lot of the same things. So that's where this is going to kind of save you. It really stinks having to rewrite the same code in several ways or in several different places, because you need the same logic in several different modules. So what we could do is create one module to perform the logic and return to us the information that we need. Python and all programming languages come with lots of different pre-written functions for us. You've already used quite a few, like print and input. Randomness we introduced about a week ago with the guessing game that we did. Remember, we have like a rand_int function that will return a random integer between a low number and a high number. There's also a math library that we can use, and that's full of functions that you can pull from. So if you ever need, say, the sine of a degree measure or the cosine, or you need to find the absolute value or the square root of or the power of anything, there's all sorts of stuff in there. So feel free to explore those two modules as you want. Just kind of Google them. I'll post the PowerPoint slides as well, so you can click on these links, and they'll simply bring you to a page where you can start to see what these things are that you can use, like math.ceil, math.factorial, math.floor, so on and so forth. So keep that in mind, something useful to use as you start going through, so feel free to click through. So when you're writing your own function, let's just talk about how it differs than a module. With a module, we would write just the word module and the module name, and then the statements inside the body that it would perform. A function needs to be a little bit more specific than that, or especially when we're doing it in pseudocode. First, we're going to start with the word function instead of module to kind of indicate that it's going to give us something back. And then in the heading, we also have to include the data type of the type of information it's going to give us back. So whether or not that be an integer or a float value or a Boolean value or a string or maybe even another object. But we need to know what that is so that we can use the function appropriately, which is really kind of necessary. Obviously, we're going to need some sort of function name, something like get total or calculate sum or count people or whatever it may be. And then there could also be parameters that are required for this function to work. There'll obviously be some statements in here that tells us what to do with the processing. But what's down here is, instead of just having a return that doesn't actually go anywhere or give us anything, it'll have a return plus some sort of value associated with it. So this will be what it actually returns to me, the actual information that it's giving back. When you look at it in like true pseudocode, you might have a program that looks a little bit like this. So here's the actual mainline logic that kind of comes through everything, and then I broke things down into smaller parts over here and here. So over here on the right hand side, we have module main, where we have local variables for the age and the second age of the person. So essentially what we're trying to do is gather the ages of two people and then total them, okay, and come up with a sum. So what it's doing is saying, okay, enter the ages of the people, and then we call this function called sum. And we've already pseudocoded that function sum here, and I even broke it down a little bit further over here. But function sum returns something of type integer, and it requires two integers to get passed into it. Okay. Once I have those two integers passed in, I can declare some sort of result. I can sum that result here, set it, and then return it back into the program. So you're going to notice that when I use the function up here in the actual mainline logic, it says sum of first age and second age. Well, since it returns a result, I have to use it in a way that that information doesn't get lost. So this is where I set the total equal to whatever comes out of the sum. And so you can kind of see it broken down over here a little bit. So I've got function integer. This little part tells us what the return type is. Here's the function name, and obviously the parameter list that kind of comes through. I do the work that I need to do, and I return the result. The trick, though, is usage. This is what's a little bit different. You have to use a function in a meaningful way. And what I mean by that is you have to use it in an assignment statement, something like this right here. You have to use it in maybe a conditional statement, an if statement, or a while loop, some sort of heading to something, or maybe even in another method so that it can be useful information for an argument for that method. So that's what we have going here. And since this function returns something of type integer, I can set it equal to something that's meant to accept something of type integer, which is really pretty useful. All right. So when we're writing a function in flowchart form, same basic idea. Instead of start stop, we again put the module name there, and we include the parameters that it needs. We do the processing, whatever that may be right here. But what the big difference is between a function and a module when it comes to flowcharts is that there's not just a blank return statement here. It doesn't just say the word return and that's it. It returns something. In our case, it returns the result. That way, when we get back into the actual mainline logic, the flow of the program, we can see that that's coming in and we can work with it from there. Okay. So return statements are useful very, very useful. You can actually really decrease the amount of code that you have to go through by using them appropriately. The return statement doesn't have to be just a variable or a value that's held in a variable. You can actually return an expression. Okay, you can return an arithmetic expression, you can return a Boolean expression, you can even return maybe another call to a method. Okay, and that, especially if that method is of itself, that's what we would call a recursive method, a method that kind of calls itself as we go through, which is an interesting way of going about it. We'll see an example of that as we start talking about searching and sorting algorithms. But either way, we can really shorten kind of this code up a little bit without declaring any extra variables or doing any extra math. So instead of taking it from 3 lines of code, we can actually turn it back down into 1. Let's just take this sum and return num1 plus num2. It will do the math and return the sum. I don't need to come up with this result variable anymore. So as we practice a little bit, we'll show you different ways to write these functions so that they're as effective as possible. It doesn't really make it any more efficient, not by much anyways, but it does make it a little bit more effective and cleaner to read. Okay? So we talked about modules or functions being very similar to modules. The biggest difference is not just in that return statement, the biggest difference is in its usage, to be perfectly honest with you. There are basically 3 ways for you to use a function when you're calling it, okay? So here's a function that says find area. It finds the area, takes in a length and a width, and returns the length times the width. When you're using it, you want to use it either in an assignment statement, so come up with a variable, make it equal to the function call. Use it in a conditional statement, so like if area of 4 and 3 is equal to 12, do something, otherwise do something else. Or maybe you have a second function that requires the area of whatever it is you're trying to find as an argument to itself. So you can actually call that function in the arguments list for another function that you're working with. And this function happens to be another return function, which is kind of neat. So we're actually going to code this out so you can kind of see it happening all in real time and in these different ways and what it can do. So let's take a quick pause over and we'll flip over and do some coding real fast. So I'm going to come up here to module 5. We've got a project there. Let's make a Python file. We'll do this called an area example. Right. We'll zoom in a little bit. Okay, so first things first, I'm going to make that function for the find area. All right. And find area requires 2 arguments, a length and a width, or you can call them basically anything you want. It doesn't make any difference, so it could be length and width. Okay. Functions, just like modules, require that. Notice that in pseudocode and in flowchart form, you need that return type, but in Python, everything gets returned basically as the same amount of memory, so we don't have to declare a return type. If you're working in, say, Java or C, then you would have to show what that data type is going to be in that function heading. So some of the differences in languages there, you just have to kind of figure out. So like the flowchart and pseudocode said, we can do a couple things. We can go result, or I can say area equals length times the width, okay? And I could return the area. And there's that function, and I could use it pretty appropriately, pretty easily. So I can go def main, right? And I could do something like make a couple variables or a couple input statements like length equals int input enter the length space. Oops, my bad. Width and input width. Just close those parentheses, and then we'll do a quick find area. So we'll say our area. We'll just go area equals, and then we'll say find area of length and width. Okay. Now, I don't have to have the variable names the same from top to bottom, from function to function. That is completely by coincidence. It just makes sense that they are the same. If I want to change this to be a little bit shorter as L and W, that is absolutely appropriate. You just have to make sure you spell it the same way all the way through. So area equals L times W, and it all works appropriately. I still have length and width. And so now all I want to do is print the area of my rectangle. So I might say something like area is, and then I'll print area. Okay. Last thing we want to do is call the main method, so we're actually using it. So we'll do that. Main. Whoops, didn't want that twice. Now let's run the program and see what happens. So down here, it says find the length. Let's say I enter the length as 6, the width is 5 units, area is then 30. So it's pretty positive feedback. I know that's going to be right, and I can use this function, like I said, in an assignment statement. Okay, I could have completely eliminated the assignment statement and used it inside of another function. Print is just a function, so I could have easily just said find area of length and width here. And that would be just fine. There's really no reason to make this variable unless I'm going to be using it for some other purposes, right? And so now I can enter the length as, say, 20 by 10, and it should give me 200 square feet or square inches or whatever it may be, okay? But again, the third option, so we showed it as an assignment statement. We showed the method call being used in another function. We could talk about it in terms of an if statement if we want. We could say if the area, if we'll go find area of length and width is, say, greater than 100. Okay, we could say something like print plenty of room, else print need a bigger space. Okay. So we'll get rid of this here. And now I'll call the main, and we'll type in everything we want to type in. Let's say it's something like 5 by 6. Well, that's 30. It's going to say we need a bigger space. So it found the area first, and then judged whether or not the value it returned was greater than 100. Well, 5 times 6 makes 30, obviously not greater than 100, so it's not going to quite work. So let's try it with something that does. Let's zoom in on that. Let's try something that's like 10 by 15. That's plenty of room because 10 by 15 will make 150 when I multiply them together. 150 is definitely greater than 100. So again, here's another way of using it. Okay. So functions are really easy. You just have to make sure you define the module, give it a name, give it your parameter list, do the processing you want. But the trick is have that return statement in there that will return what you want. Okay. Now we could have even written this a little bit simpler. We could have just simply said return L times W. And again, it will still do the work for me prior to making the return. And if I run it again and I type in those same numbers as before, say 10 and 15, it still returns that we have plenty of room as it comes through. So you can start to see how the functions kind of work and build a little bit. So they're pretty simple to work with. Okay. So back to this. Let's do another problem. We'll kind of break it down pseudocode, and we'll actually then code it out so you can see how it works. So here's a quick practice. Let's say we want to come up with a function that can identify if a number passed to it is prime or not. Now, if you're not sure, a prime number is a number that is only divisible by 1 and itself. So we cannot divide it by any other number except for 1 and itself. So for instance, 5 is a prime number. We can't divide 5 by anything other than 1 and 5 evenly. If I divide it by 2, I get a decimal. Divide by 3, I get a decimal. Divide by 4, I get a decimal. But not until I divide by 1 or 5 do I get 0 as a remainder, nothing else. 6, however, is not a prime number because it's divisible by multiple things other than 1 and 6. It's divisible by 1, 2, 3, and 6. The 2 and the 3, making it divisible by, make it a non-prime number. So let's start with that. I want to come up with a function that will return Boolean. It'll return true or false. True if it's prime, false if it's not. And then I want to try to design another function using this function as an abstraction to display all the prime numbers from 1 through 100, or really 1 up to any number I want, which would be kind of nice. So let's give that a shot and see what we can do with it. So let's pop over here. I'm going to make a new file just for pseudocode. We're going to go prime pseudo. Okay. And we'll just make that a text file just so that we've got something to work with. All right, so let's kind of pseudocode this out and see what happens. Obviously, we're going to want a function. It's going to return Boolean. Okay, and we want it to be called, say, something like is prime. It seems to be an appropriate one. And we need to pass in some sort of value, which is going to be of type integer. Okay. So here's my function heading. Now I need to talk about how this is going to work. Well, how am I going to determine if a number is prime? Well, let's just, for instance, assume that whatever the value is that's passed in is prime. Let's assume every value is prime until we can prove that it's not. And how can we prove that it's not prime? Well, we can try dividing it by every single number from 2 up to the number but not including it. And if any of those numbers are evenly divisible by the value, or the value is evenly divisible by any of those numbers, I should say, then we can say that it's not prime. So let's go ahead and look at that logic. So like I said, let's assume for now that it is prime. So I'm going to come up with a variable called prime, and I'm going to set it equal to true. Okay, so I'm going to make a declaration. I'm going to declare a variable, a Boolean variable. I'm going to set it equal to true. Okay. After that declaration, let's go through some processing. I want to come up with basically a loop, okay, a for loop. So I want to come up with a looping structure that'll loop through every value from 2 up to the number, but not including the number. So let's do this. We'll go with something like a counter, or we'll just do a for loop. We're comfortable with for loops now, so we'll say something like for our I value, for I in range of 2 through our value. And again, pseudocode, when we start writing it, can start to look a little bit more like Python as we start going through. We don't want it to look exactly like Python, but we have a language in the background. We know what we're going to be tailoring it to. It's kind of nice to have that. So let's just kind of use it a little bit. We can really break this down to where it's counter controlled and while loops and things like that, and that's fine, but we have these tools, we might as well use them. So for I in range of 2 to value, so what that means is start at 2, work your way up to but not including the value, and we want to check and do, and we want to see is I, or is value divisible by I. So if value is divisible by I, what do I want to do? Well, then I want to set prime equal to false. Right? And if that's true, that would be great. Once I'm done checking all this stuff, I want to return the value of prime. If we never did this, if this question never came out to be true, then the prime value would never come and turn to false, which means it was prime. Our assumption at the very beginning was correct, and so we kept it, right? So let's come over here and try coding that real quick and see where it takes us. So we'll call it our prime. Zoom in on this. def is prime, and we're going to pass in a value, okay? Remember, we don't make declarations, data types in Python, so it's going to look a little bit different, but we have the right idea. Let's come up with a variable called prime. We're going to set it to true. In Python, true and false have to be spelled with uppercase T or uppercase F. And like I said, we're going to loop through every value from 1 up to but not including value. Technically, we don't need to go that far, but we'll keep it simple. So for I in range of 2 through value. And I don't want to include value. Value would always be divisible by itself. That wouldn't make any sense. I want to check to see if my value mod I, our Remember, I is taking on a number. It's taking on 2, then 3, then 4, then 5, then 6, then up to whatever value might be, but not including value. And if that ever comes out to 0, meaning there's no remainder in the division, then I know that this number is not prime. So I'm going to say prime equals false. Oh, again, spell false correctly. Now the trick here is I want to get all the way out of the loop, and I want to return prime. Okay. So now let's make a little program and kind of test this out a little bit. Let's go def main. All right. We'll call the value, and we'll just simply print out what it does. We'll see if it's true or false. Okay. So we'll say something like print is prime of 5. Okay. Let's just see what happens there. Let's call the main method. Okay. And let's run the program. So if I plug it in, 5 comes out. You can read that down there. It says true. Okay, well 5 is a prime number. That's kind of nice. Let's try plugging in 6. Run it, see what happens. And that came out false, which is good. 6 is not a prime number, so it should say false. Let's check it with a couple more, maybe something a little bit bigger, like 97. Okay, that comes out true. 97 is a prime number. And let's try something like 90. 90 is divisible by 10, 5, 2, 45, all sorts of numbers. So it came out false. So it seems like my is prime is working. Okay. If I'm looking at this though, I could probably clean it up a little bit. You're probably already looking at like, why bother with all of this? There's a couple things here that we could clean up quite a bit. So first of all, if you wanted to, we could rewrite this a little bit. We could actually eliminate most of this. Like I could comment this out. And this return statement could change a little bit. Now the logic still has to stay. I still have to loop through some things. I don't have to loop through as many, but I still have to loop through some things. But I can make these return statements work for me. So instead of saying this, I could say return false. All right. And down here, I could say return true. Now the advantage of doing something like this is now I don't have this extra variable. Okay. And return statements, once reached, exit the method completely. So let's say I did have a number like 90 in here. Now, before, this had to actually set the value of prime to false several times because 90 was divisible by several numbers between 2 and 90. It was divisible by 2, 3, 10, 5, all sorts of values. But here's what this does. When I go through this loop, for I in range 2 to value, if value mod I equals 0, so if it's 90, if 90 mod 2 is 0, which is true, this is going to return false, and it's going to stop everything and just kick me out of the entire method, not just out of the loop, but out of the method in total. So it never even reaches the value of 3 to check because it didn't care. What was the point? We already proved it wasn't prime. So I've really kind of sped things up quite tremendously, especially when I'm looking for numbers that aren't prime. Now, if a number is prime, it still has to loop through everything because this condition will never be reached. It still has to finish the loop. But if I do finish the loop and I never hit this return statement, the only block of code left or line of code left is to return true, and so that's where I get the value of it being prime. So this actually still works really well. So if I type in 90, you're going to see that it comes out false. If I type in something like 93 or 97 again, it should come out true. Okay. Now, you don't notice any lag in time there or anything else because we didn't make it really any more efficient on the prime values, but we did make it significantly more efficient on the non-prime values. So that's kind of important that you want to take care of. All right. So then the last thing, let's come up with another function that can utilize this function to help me that will display primes up to a given number or up to 100. So let's make it so it goes up to any given number. So let's go def display primes. All right, and we're going to talk about a value here. We'll say up to value. Okay, and we would display all the primes up to whatever this value is that we pass in. Okay, so realistically, what I want to do is loop through every value from 2 up to this value right here, and I want to check to see if it itself is prime, and if it is, print it. So let's try that. Let's go with this. We'll go for I in range of 2 all the way up to value plus 1. The reason for the plus 1 is I'd really like to include that value that I pass in by argument. Okay? So for all of that, what I want to do is check to see if it's prime. And I really can just say it simply like this. If is prime of I. Since this function returns Boolean, I can use it in the context of anything that allows me to use a Boolean value. An if statement is looking for a true false. Since this function returns true false, it's the perfect time to use it. So when I pass in 2, it's going to say is 2 prime, true or false. And if it's true, do whatever I say down here. And what I say down here to do is to print. I want to print the value of I, and I want to print the word is prime. Okay? And if it's not, I don't really want to do anything. So it's just a one-way selection. I don't want to print anything else. So down here in my main method, instead of determining and printing out a single prime value, what I'd like to do is display primes up to, say, 100. Now let's do something smaller. We'll just do 10 at first, just so that we can make sure we notice them all. So we should get 2, 3, 5, 7, and that's about it. Okay, so let's see what happens. 2 is prime, 3 is prime, 5 is prime, 7 is prime. And now if we do it up to 100, we should get a lot more numbers in there. And there we go. 2, 3, 5, 7, 11, 13, 17, 19, all the way down to our good old friend 97. So that's kind of the beautiful part about functions, is that once you write the code, you can actually use the code a little bit more flexibly. You can use it in many more situations. And if you write them to return the right type of information for yourself, they're very, very flexible. You can use them in so many other situations for yourself that you really reduce the amount of code that you have to write, and it becomes a lot easier to troubleshoot. Because if you have a function that's just not working, let's say it's not returning the right prime numbers, then I know something's wrong in here. It is prime. If I know it's not displaying enough numbers, but it is calculating the right primes, then it's something wrong in here, and I can troubleshoot it a lot easier. So hopefully that kind of helps with some of the function work. We're going to do more of those as we get into some more examples a little bit later on in the next couple of videos. We start talking about strings and validation. Keep that in mind. You're going to get some more practice with that. But that's it for this video. Hopefully that kind of helps you out with functions and how to use them. And we'll have some time to work with them as we go. Okay? So take care. We'll see you in the next video.